Hello and welcome to Vectors Day 3. There will be just a little bit of drawing vectors here, but really not too much, so if you don't have graph paper, that's okay. We can do most of this without. So Vectors Day 3, we're going to focus on the dot product and finding the angle between two vectors. Now in the last video, we focused on finding the direction angle of a vector, meaning the angle that a vector makes kind of with our axes. Now we're finding the angle between two vectors. And to do that, we need our dot product. So to find the dot product, let's say we have vector v with v sub 1 and v sub 2. We have vector w with w sub 1 and w sub 2. V dot w is v sub 1 times w sub 1 plus v sub 2 w sub 2. So the dot product is not necessarily multiplying completely. We are multiplying our x values, multiplying our y values, and then adding those together. So if we have an example where we have vector v is 2i, minus 3j, and vector w is 5i plus 3j. If I was to find the dot product of these two, so if I was to find v dot w, that's going to be, that's going to be 2 times 5, so the x values, the I values of both of these, plus the y values or the j values of both of these multiplied together. So negative 3 and 3. So that's going to give us 10 minus 9, or 1. So if we were to try this again, what if we try to find the dot product of vector v dot vector v? Well, that's going to be 2 times 2, our i's, plus, wrong color, there we go, plus negative 3 times negative 3, or our j's together. So in this case, that would be 4 plus 9, or 13. Let's try one more. What if we had 2v dot w? So in this case, we'll have 2 times our vector v of 2i minus 3j. We're finding the dot product of that with 5i plus 3j. First, when I multiply the 2 into my vector j, that's going to be, into my vector v, it's going to be 4i minus 6j dot 5i plus 3j. So from here, once more, multiply my I terms together, so it'll be 4 times 5, and add those to my j terms, which will be negative 6 times 3, or 20 minus 18, also known as 2. So these are all examples of our dot product. And we need this dot product in order to find the angle between two vectors. So let's take a moment and practice that. Finding the angle between two vectors. Now when I draw these vectors, I'm going to draw these freehand. This might be the time where you want some graph paper, but if you do not have it with you, that is okay. So when we are trying to find the angle between two vectors, it might look something like this. If I have my vector v somewhere right here, and my vector u, let's say somewhere right here, I am going to be looking for this angle theta, the angle between these two vectors. So when we're trying to find that in general, we're going to find that by cosine of theta is equal to u dot v, so not multiplying, but the dot product, over the magnitude of u times the magnitude of v. So we're multiplying on the bottom, but not on top. This actually has to do with our law of cosines. The proof can be found in our textbook on page 631, but right now I'm just going to say, trust me. So again, we have vector v and vector u. We're going to say that vector u is 4, 3. We're going to say that vector v is 3, 5. And I'm trying to find the angle between these two. So first thing, just like we practiced, I'm going to find the dot product of these two vectors. So that's going to be 4 times 3 plus 3 times 5. So that's 12 plus 15, or 27. Now we need to find the magnitudes of both vector u and vector v. So the magnitude of vector u, just a reminder, we take the square root of our x value squared plus our y value squared. So in this case, that is the square root of 16 plus 9, the square root of 25, also known as 5. So the magnitude of vector u is 5. And then the magnitude of vector v is going to be the square root of 3 squared plus 5 squared, or the square root of 9 plus 25, or the square root of 34. And I'm just going to leave it like that. So now that we have our dot product, magnitude of vector u, and magnitude of vector v, we're going to put this all together to find our angle. There we go. So when I'm trying to find my angle, we'll find cosine of our angle is equal to that 27 over 5 times, oops, I'm going to erase that, there we go, 5 times the square root of 34. Now if you're able to, please simplify your fraction. I know that we normally rationalize here, but since we're about to plug this into a calculator, I'm fine if we don't. To solve for our angle, we need to use cosine inverse on both sides. And from here, once we plug this into our calculator, we get that theta is equal to 22.17 degrees, saying that the angle between vector u and vector v is a little over 22 degrees. So all math that we know, just kind of bringing it all together. Now we're about to do a lot more practice, and there's a lot more practice in the completed notes, but before I finish this video, I want to talk about why this might be useful to us. When we're looking at different vectors and we're looking at their direction in accordance to each other and what their angles might be, there are special types of relationships between vectors. Mostly we've been dealing with vectors that are just kind of like creating an angle, no big deal. But we do have 2 different types of angles that I want to discuss right now. One of them is if we have parallel vectors. So if we have parallel vectors have the same slope. And this is going to be important to us to recognize because they create -degree or 180-degree angles. It's possible that these 2 vectors might be equivalent to each other. That's something we would have to check later on. So we're going to be checking to see are vectors parallel, meaning that when we find their angle, they're either 0 or 180 degrees. Or we might also have orthogonal vectors. Now, orthogonal is just a very fancy word for perpendicular. Because they are perpendicular, meaning that they are creating 90-degree angles. Kind of a shortcut for this is if the dot product is 0, the vectors are orthogonal. That's because when we're trying to find our angles and we need to use cosine inverse, 0 divided by anything is just 0. So if we have cosine of theta is equal to 0 over literally anything, except for 0 itself. I do want to specify except for 0 itself. If we're trying to find out what theta is, cosine inverse of 0 is always going to be 90 degrees. So I would still want you to maybe show some work here, but otherwise, we already know they're orthogonal. So again, we're going to do a lot more practice in class, and there's more practice in the completed notes. But if you have any questions, please let me know.